I'm Kalyn Diederich. I'm a third-year PhD candidate at University of California, Davis. Originally from Northern Colorado, I got my Bachelor's of Science degree at Colorado State University. From there, I transitioned to UW-Madison, where I got my Master's of Science in Agroecology and Soil Science. Now here at UC Davis, I am a PhD student in the Soils and Biogeochemistry graduate group. My dissertation research largely focuses on the novel perennial grain crop known as Kernza. Kernza is an agronomic crop that produces a wheat-like grain that we can make cereals and beers and breads with. However, unlike annual wheat, we do not have to till and replant Kernza each year because it's a perennial. Prior to 2017, in the U.S., most of the research on Kernza has taken place in the Midwest and the Northeast USA. So my advisors and I in 2017 started the first long-term field evaluation of Kernza in the state of California, as pictured here, where we compare Kernza to both till and no-till annual wheat along gradients of nitrogen fertilization and irrigation. When I say compare, I mean comparing above ground productivity, so looking at total vegetative biomass and grain yields, as well as below ground productivity, such as the active soil microbial community composition. For instance, if we see here on the slide, we are looking at PLFA, or phospholipid fatty acid analysis, which is an analysis of the active soil microbial communities in these three different cropping systems. And each cropping system is within one of these ornithopsis or circles. And all we need to know about looking at this figure is that if these circles are closer to one another in this CCA figure, then the active microbial community composition is more similar across these systems. And if they're further apart, then they're less similar. In the first year of the experiment, 2018, we see that all of these three systems have a fairly similar microbial community composition. However, by the second year, 2019, Kernza is very clearly differentiating from the till and no-till system. By the last year of the experiment, 2020, we see yet again that Kernza is clearly differentiated from the till and no-till annual wheat system. What this suggests is that perenniality versus just a lack of disturbance, which is emulated in the no-till system, may be driving changes in active microbial community composition over time at a 0 to 60 centimeter depth. This is important because one of the objectives of this research is to try to understand the underpinnings of soil ecosystem services. Another one of our objectives is to try to provide agronomic data for growers in the region on Kernza so that they can make an informed decision on whether or not Kernza is appropriate for their agroecosystem operation. If you'd like to learn more about this, please check out my poster. Thank you for your time, and thank you, ARCS, for your support.